so the volume of a sphere is 257 centimeter cubed. Find the radius of the sphere. Okay, so first of all, we have to set up our formula, which is volume equals 4 pi r cubed over 3. You can do this isolation step by step, or you can do it all together. It's all up to you. So how would you isolate for R? What would you do? Well, first of all, let's set up the volume to be 257. Right? So you replace the volume with 257. What do you do to isolate for the radius?
First
Multiply by 3. Okay, then?
Then divide by 4 pi.
Then divide by 4 pi, right? So, I mean, I've seen people who did it step by step. First, they multiplied by 3, then they divided by 4, then they divided by pi, right? Which is good. That's fine. If that's how you, you want to do it step by step so you see what you're doing, I'm totally okay with that, okay? I'm going to write it one step. So I'm going to multiply by 3. And then we're going to divide by 4 pi. Make sure that when you're dividing by 4 pi, you're putting it in bracket. Okay? And that's going to leave you with r cubed. So what was the answer for this? 61 point
35.
35. Okay? Then to isolate for r, you're going to cube root. If you can't find the cube root on your calculator, you can also find a root that has kind of like an empty or an x here or whatever it is, right? So what you can do the root with and then you put a 3, okay? So you can do the cube root. And then some calculator already have that button in there. You will need to use this if you have anything above 3, because most of the calculator don't have like the 4th root or the 5th root or whatever root, right?
Yeah, 61.35 and then
Yeah.
the cube is
Yeah.
shed.
That's fine. You'll have a more accurate answer.
When I did that, I did wrong.
So what do we get for this?
The cube is
What is it?
3.94.
3.94. And that's going to be centimeter. Okay? Questions? Okay. I should be able to go over one more thing here. We have a lot of time now, right?
Yeah, the function is only.
Why did you put 771?
Yeah, so it's all the way.
Did you divide by 4 pi? Okay, you need to divide by 4 pi first. Are you guys still okay if we go over another lesson? We're good?
Yeah, still have to. We can finish it.
We're good? No, not optimization though. We won't do optimization today. Optimization is a big one.
And there's only one paper or 2 papers?
So which one are we, pyramids?
Yep.
So, moving to the pyramids. In this case, we don't have to deal with square-based pyramids because it's easy to calculate the volume. The question to you, if you look at this formula, volume equals 1/3 length times width times height. Does this remind you of anything? The formula, volume equals to 1/3 length times width times height. reminds you of the length of a prism, right? Or of a rectangular prism. So if I just hide the 1/3, right? It's the same thing as the rectangular prism. Remember that? LWH.
Yeah.
So that means a pyramid is 1/3 of a prism. The volume of a pyramid is 1/3 of a prism that has the same dimension. Okay? So you can fit 3 pyramids in a prism, in a rectangular prism, right? That has the same dimension. You have to always think about the same dimension. Now when I'm talking about the length, the width, and the height, where would the length and the width go, and where does the height go? So the length and the width are your square base, your base, sorry, yeah. So your length and width are going to have to go in for your base, and then the height,
Is the middle one. It's 25.
the vertex, yeah. So the height is actually the height of the pyramid. Remember when we were talking about the surface area, what height did we use? The slant height, that's right. Right? So when we're talking about volume, we have to use the height of the pyramid, okay? Not the slant height. Remember that the slant height is the height of the triangle. So that would be the slant height. All right, so I need the length, I need the width, and I need the height of the pyramid. Which in this case, I have all of them. So the volume is 1/3, or if you want to write it as LWH divided by 3, whatever you want, right? You can write it either way, like this or like that. And that's going to be 18 by 15 by 25, all divided by 3. And the answer is going to be 39,750.
2,250.
Yeah. I probably entered the 0 by mistake somewhere. 3375. Is that what you guys got? Come on. It's 18 by 15 by 25, right? 18 by 15 by 25
Over 3.
divided by 3.
Is 2,250.
See? My calculator. So you need the height of the pyramid, otherwise you can't calculate the volume, right? How about for this one? I gotta find the height. What's given to me?
This one.
Less than height. And how can I find the height?
I put here, here, and I put here.
Pythagorean theorem.
You also gotta cut the 26 in half to find the other side.
Perfect. Okay, so remember that when you're forming the right angle triangle, right, you're forming it with half of one of the sides. In this case, half of the side here is half of this side, right? So I'm looking at half of 26, which is 13, right? And I have the slant height. So if I'm going to draw my triangle here, I have 13 and I have 22. I'm looking for this. So what would my formula be?
22 squared minus 15 squared.
That's right. So if I'm looking for, let's call it A, right? So it's going to be A squared equals to C squared minus B squared. Which is going to be 22 squared minus 13 squared. And then to find a square root, 17 point. Make sure that the height is going to be less slanted height. All right, now I have the height and I have the length and the width. It's a matter of just plugging it into the calculator. one we're gonna do today. Correct.
What about the last one?
Optimization, that's gonna be tomorrow. Okay. That's fine. What's going to be for the, is it 17.75 you said? And then how is it gonna change this? What? 69? All right. How about the volume of a cone? What do you see? What can you compare it to? The volume of a cylinder, right? It's 1/3 of that, right? Again, if you have the same radius and the same height, you can fit 3 cones in 1 cylinder. So a paper cup is in the shape of a cone, has a radius of 3.2 and a height of 6. How much water can the cup hold? Now, because they're asking you for how much water can the cup hold, you probably don't want to leave your answer as a centimeter cube or as a meter cube or whatever, right? Because they're looking for the volume, and then if I come and tell you, well, it can fit 200 centimeter cube of water, right, you're going to look at me sideways, right? When they ask you for a volume of a liquid, try to convert it to mils or liters, okay? So, the volume here is 1/3 pi r squared h. I know the radius and I know the height, so that's going to be pi times 3.2 squared times 6 divided by 3. .34 centimeter cube. Okay? So because they're asking you how much water, you can say that,
64.34 milliliters.
yeah. So it can fit about 64 milliliters. Because remember that 1 centimeter cube is equal to 1 milliliter. Okay. Last but not least, find the volume of the following figure. So what do I need to do? What formula and what do I do?
Find the volume of the first one and the second one.
So I have to find the volume of one and the second one and then add them together, right? Because this is a composite figure with 2 cones, right? What's special about the 2 cones is that they have the same radius, right? But then different height. So the volume of one is pi r squared h divided by 3. which in this case is going to be pi times 6 squared multiplied by 24 divided by 3.
Let's try it, maybe I know.
How come I got 904?
Oh, sorry, so for 24, no, for 24 it's 904.79.
Okay. All right, now, you can take a 5-minute break. When you come back, other than the homework that you have to do, the too many pages of homework that you have